Okay, let's look at 4A. I have 5 cards are dealt from a standard 52 card deck. Find the chances, the probability you're dealt no more than a single jack. Now, there are 4 jacks in a deck of cards, okay? I can't get any more than a single. So this one I think is a little bit hard to think about. It was for me. So the way I looked at it is I looked at the probability of getting no jacks, okay, or I looked at the probability of getting exactly one jack, okay, because that means no more than one. I could get no jack, or I could get exactly one. So when we have the idea of or in probability, this could happen or this could happen. We can literally just add the two probabilities. And for me, this was the easiest way to work this problem. So we've got 48 cards to choose from. We're going to pick 5. 48 of those cards are not jacks. Okay, 48 of those cards are not jacks. That's why we use the 48. 52 combined with 5. This is the total number. So I'm going to add that. Now I'm going to get my possibility of getting exactly one jack. So there are 4 jacks in a deck of cards. I'm going to choose one of those. But I also have to multiply that by the probability of not getting a jack. And I'll say the words for that in just a second. So here you go. This is the probability of drawing a jack, and since we're drawing 5 cards, the probability of not getting a jack. So we've got to take out those 4 for 48 other types of cards. Then we're going to still divide that by 52, choose 5, which that is a common denominator. So if you wanted to simplify that out a little bit, you can enter this directly in your calculator all over. But I think because we've got some terms here in the numerator, do you see the 2 terms? If I were you, I would put those in parentheses. So when I did the math, I did each one separately so you can test it and see what you're comfortable with on your calculator. I rounded that to about 5 places. So then on this one, I got 2.9947. And then I literally added those together and got 0.958315634. Whatever MyLabs Plus says for your answer, just be sure you round it to those decimal places. So this is what you should get for that expression. I think the wording is a little bit challenging on that, and that's okay to feel a little uncomfortable. So on the B part, we want to find the chances you're dealt a flush of hearts. Now, a flush is where you have all hearts, okay? So this is the first part. This is the probability of a flush of hearts. Okay, now we're drawing 5 cards. They all have to be hearts. Okay, so to make that happen, then we'll have 13 hearts. There are 13 hearts, spades, diamonds, and clubs. So I'm going to choose 5 of those. Out of the 52 cards I have, and I'm picking 5, that should give me 0.000495198. So if you'll look at that in percent form, okay, you've got about 0.05% of a chance of getting a flush in a card game. All right. Now, to get a flush in general, that could mean a flush of hearts, a flush of spades, a flush of clubs, or a flush of diamonds. So the probability is going to be the same because the numbers are the same. So the way we want to look at that is I want the probability of getting a flush, but there are 4 of those, and that's the same as the probability of the heart flush. So you'll just multiply 4. Oops, I better write that correctly. Okay, I think you can also, I would just be safe and do that. And when I did that product there, I got 0.00198, 0792. If we look at that in percent, okay, there's your percent right there. So you might have almost 0.2% of a chance of getting a flush in general of any kind. So it's a little bit difficult to make that happen. Okay, let's look at a car dealership. All the different ways you could buy a car. We'll try to crank through these pretty quickly. Okay, we've got a dealership. We have 5 red cars, 12 black, 8 silver, 4 blue, and 1 white. They're choosing to put 8 cars out on front for display. Okay, we want to find the probability that they will choose 3 reds and 5 blacks. Probability, 3 reds and 5 blacks. Okay, so I want to use this full notion of subgroup and show you the nice check that goes on with that. I didn't do it back here in the beginning, but I want to finish it up here so I can show you why there's things that I can absolutely leave out. So I have 5 red cars. I'm going to choose 3 of those. Times, I've got 12 black cars, and I'm going to choose 5 of those. Now, what about, I talk about the possibility of things not happening. So we still have 8 silver cars, but we don't have any of those in our probability. We've got 4 blue cars, but we're not choosing any of blue cars. And we've got 1 white car, but we're not choosing any of those either. Okay, so let me go ahead and get your total. There's 30 total cars when you add up the 5, the 12, the 8, the 4, and the 1. Choose 8. Okay, so what I want you to do is on your calculator or using your formula, you'll notice that when you enter 8, choose 0, that'll give you a 1, that'll give you a 1, and that'll give you a 1. So those 3 factors we don't actually need. So we're content to just look right here. But as I showed you earlier, the 5 plus the 12 plus the 8 plus the 4 plus the 1 has to add to the 30. The 3 and the 5 and the 0 and the 0 and the 0 have to add to 8. So these to me add a nice check that you have this part set up correctly. So when I did the math on that, I got 0.00135,317. So moving on, find the probability that they choose 2 red cars, 3 black cars, and 3 silver cars for the display. Okay, so we'll have 2 reds. So we're going to have 5 reds, choose 2. And, see, there's that multiplication. And we've got 12 black cars. We're going to choose 3, and we've got 8 silver cars, of which we're going to choose 1, or actually, let's see, 2, 3, and 3, okay? Then we're going to divide that again by 30, choose 8, okay? So this is the red, this is the black, this is the silver, okay? I could do the same thing with the times 4, choose 0 blues, times 1, choose 0 white cars. 021049304. That probability in your decimal form. Find the probability that they choose exactly 6 black. Okay, so there are 12 black cars. We will choose 6 of them. Divided by 30, choose 6. Okay, and again, we could follow through with this same kind of idea for the ones we didn't choose. We're knowing that they'll turn into a factor of 1. And we get that probability for our answer. So to finish up this page, let's see what remains here. Okay, to finish up this page, we want to find the probability they choose exactly 3 black cars and 2 silver cars. So probability of exactly 3 blacks and 2 silver. So I've got 12 choose 3 on the black times 8 choose 2 on the silver divided by 30 choose 5 because we're choosing 5 total cars for the display. And we have our probability there. Again, just look at MyLabs Plus and see what they're asking for. Do they want that in decimal form, or do they want the setup, or do they want it in percent? And then be sure and look to see the number of decimal place they want things rounded to.